game where you toss a fair coin over and over, and your payoff starts at $2 and doubles every time tails appears, but the first time we flip heads, the game ends, and you win whatever the payoff is. So just for a moment here, let's work through a couple of our first cases, right? You win $2 if heads appears right away, $4 if tails appears first, immediately followed by a heads, and $8 if two tails appear before the first heads, and so on and so forth. So using that fact that our coin is fair, we get these following probabilities here for each of these events. And so if I asked you what you would be willing to pay to play this game, right, you might be like, okay, 20 bucks max. But if we look at our expected value from playing this, right, just by writing out our cases here, you'll see that we get this guy by definition. And then wait a minute here, this kind of looks like an infinite series we might know. So by just saying the player wins 2 to the n dollars with probability 1 over 2 to the n, we get this infinite series here. And then we see that these terms cancel, and obviously adding up 1 infinite times gives us an infinite expected payoff. And this gap in expected payoff and what we'd be willing to pay is what we call the St. Petersburg paradox. And there's a lot of good explanations to this, but maybe the best one here is Bernoulli's idea that people neglect unlikely events, and since expectation is just a weighted average, our infinite payoff dominates the much likelier smaller payoff. So yeah, we're done.